In this video, we'll be going over valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So each row must contain the digits 1 to 9 without repetition. Each columns must contain the digits 1 to 9 without repetition. Each of the 9 3x3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. A Sudoku board, partially filled, could be valid, but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. So we don't need to account for these three rules. So in our first example, we have 5, 3, and then all of the periods in there are values. So we can see that all of the digits are populated, and all of the periods are considered as blank cells, and we only need to consider the filled digits. And this board is valid according to 3 rules, so we return true. Let's go over the thought process. So we will need a quick way to determine if a value has appeared at the current row, column, and subgrid. Or a subbox. We can create a string representation of each of the parts. So for example, if we are currently at, we can create a string representation for each of the parts to be stored inside a hash set for quick lookup. So we're currently at row RC with the value X. We can create a string representation of the current row. So string representation of the current row can be the current row, they're given the row number. In this case, we're going to have R, and then also the value X. And we get the string representation for the current column. We have the current column, the column number, and also the value at the current cell. Now, how can we determine a string representation for the subgrid or the subbox? We can use division. So for example, we are currently at, so this row here can be considered as the first row. So we have row 0, and then row 1, and then row 2. And this one can be column 0, column 1, and column 2 for subgrid. So in this subgrid, we're in the subgrid 0, 0, because the row is 0 and the column 0. So in this case, in this one, we have a row of 1 and the column 1, so we can call this subbox 1, 1. Now, how can we determine the subbox itself? We can use division by 3, divide by 3. So if we're currently at this cell here, which is at row 0, 1, 2, 3, 3, if we do 3 divided by 3, we get row 1. So we get a value of 1. So we can see that this is row 1. And also, we're currently at, in order to determine the column, we can perform the similar using divided by 3. So we're currently at this cell here, which is at 0, 1, 2, 3. 3 divided by 3 is equal to 1. So we can see that we're in column 1 of the subboxes. So we will determine the row using R divided by 3. Then determine the column using C divided by 3. Then we can create a string representation, which is equal to, we can call it box, and then we can have the current row, which is R divided by 3, and then the current column, C divided by 3, and then the current value, X. We can store all of this string inside the hash set, and then if the current cell has a string representation that is already appeared inside the hash set, then we know we have found a duplicate value. So let's go over Pseudocode. So create a hash set scene to keep track of the string representations. Then we're going to iterate through the columns, the rows and columns of board, which is going to denote it as RC, the current row and column. If the current cell contains a period, then we want to skip the current cell because we only want to consider digits. Continue to next iteration. Now we want to generate the current string representation for the current row. String representation x for the current row. So we can x is equal to, as we have seen here, so the current row and then the row number and the value. The value is board RC. If x is already contained inside scene, that means we have a duplicate value. Then we can return false. Else we just add x to scene. Now we want to generate the string representation for the current column. So we can call it y, and then we can x equal to column plus is equal to the c and the current value. Oh, y here. And then if y is already contained inside scene, then we have found a duplicate value at the current row. Then we can return false. Else we just add y to scene. Next, we're going to generate the string representation z for the subbox. For subbox at RC. Now we can use this similar over here. So we can have z is equal to box r divided by 3, c divided by 3, and also the current value, board RC. And then if z is already contained inside the scene, then we return false. Else we just add z to scene. Else we're just going to return true after we have validated all of the cells. Now let's go over the time and space complexity. So for the time complexity is equal to O of mn, where mn are the total number of rows and columns. So we visit each cell once. And our space complexity is equal to O of 3mn. So it's still going to be O of mn. Because we generate a 3 string representations of each cell for the row, column, and the subbox. Now let's go over the code. So we'll first create our hash set to keep track of the strings that we have already seen before. Then we'll iterate through the columns. Iterate through the rows and columns of the input board. If the current cell contains a period, we want to skip it. We want to only consider digits. Now we want to check if scene.add the current string representation. We're going to create a method to stringify the current row. If we have failed to add the string representation to the scene set, that means it has already appeared inside the set already, so we can return false. And this will also apply for the current row, current column, and current subbox. Now we have a OR loop because if we have already seen it at the current row, at the current column, or we have already seen it at the current subgrid or subbox, we can have a overloaded method. We have r divided by 3 and c divided by 3. If we already seen the value at any of these row, column, or subbox, then we can return false. After validating all of the cells, we can return true. Now let's create the method to stringify the current row and column, because we can add these to the same method. We can account for them in the same method. So our first parameter is going to be d for our direction, either if it's row or column. And then we can have the row number or the column number, and then the character value. Now we are going to return string representation using a string builder because we do not want to concatenate our strings. So we're going to first append the row or column, and then we're going to append our dash, as we've seen here. And then we're going to append our currents r, which is the current number, and then we're going to append the pound for this and for this value, and then we're going to append the value. append the value itself, and then we're going to return to string. Now we're going to create our Stringify method for the sub box. So our int r, the current row, the current cell, the current column, and also the value. Very similar to this. Instead of direction, we're going to have a box, and then we're going to append our dash, and then we're going to append our r. So append r, and then append another dash before we append the column C itself. And then we're going to append the pound and then the value, and then to string. As we can see here, the column, pound, and then the value, and then we can return the string. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview. I upload videos every day, and if there are any topics or questions you want me to cover, let me know in the comment section below.